Muy
Hey,
bueno.
Raúl.
Good.
Okay.
So good morning all, and thank you for coming. I'm presenting today my paper, The Yield Curve as a Predictor of Economic Activity in Mexico, the Role of the Term Premium. So I am at the Bank of Mexico. So for motivation, we have that anticipating the future behavior of economic activity is important for central banks in the decision-making process, because economic activity is an important determinant of inflation. In this sense, the slope of the yield curve, which is defined as the difference between the long-term interest rate and the short-term interest rate, has been used by many economic analysts as a leading indicator of economic activity, mainly for the case of the US and other advanced economies. And in particular, the attention has focused on episodes during which the yield curve becomes inverted, which could precede periods of lower economic growth and even recessions. So based on this motivation, this paper is going to analyze whether there exists a relationship between the slope of the yield curve and the future economic activity in Mexico for the period 2004 to 2019. And in particular, we're going to see if this relationship depends on the term premium. The term premium is defined as the compensations that investors demand for holding long-term assets instead of short-term bonds. The model that we estimate is a threshold model in which the relationship between the yield spread and future output measured as either output growth or the probability of a contraction depends on whether the term premium is above or below some estimated threshold. So regarding this point, the idea here is that if we have a low term premium, then the yield curve can be inverted with a small decrease in the expected short-term interest rate in the future. So in this context, it can be argued that this movement will have less predictive power to anticipate a reduction in economic activity. And the main results of these papers indicate that the slope of the yield curve seems to anticipate the behavior of economic activity only when the term premium is above the threshold that is going to be estimated. So there are two main mechanisms that can help to justify the predictive power of the yield curve to predict future economic activity. One is the relationship between the economic cycle and the risk premium. And second, the influence of monetary policy. Regarding the first mechanism, we have if we are in an expansion, then the risk premium tends to decrease, and also the long-term rates. And this tends to flatten the yield curve. And at the same time, because expansions are usually followed by recessions, then we will expect a lower decrease, a lower rate of economic growth in the future. And so that's how it comes the relationship between the yield curve and output in the future. And the other mechanism is the influence of monetary policy. If we have a monetary tightening, short-term rates increase more than long-term rates. And because of this, the yield curve flattens. And at the same time, because short-term rates are higher, then we will expect a reduction in the rate of economic expansion in the future. So that's how it comes the relationship between these two variables. So regarding the literature, there are the related literature. Some papers look at the predictive power of the yield curve on economic activity for the US, for other advanced economies, emerging economies, and even Mexico. Also, there are some papers that look at the predictive power of the two components of the yield spread, which are, one is the term premium and the other one is the expected interest rates, short-term interest rates in the future, according to the expectation hypothesis of interest rates. And also some papers look at the usefulness of the yield curve to predict recessions. And some papers look at the possibility of threshold effects that depend on different variables such as output, and time. So the contribution of this paper to the literature in terms of method, these papers allows to capture a nonlinearity with this relationship is going to depend on the term premium using this threshold model. Second, the paper is focused on Mexico, while most of the literature has focused on advanced economies. And Mexico is a particular case to analyze because this is the country with the highest investment in government securities by non-residents among emerging economies. And finally, this analysis in terms of the period is relevant because the 10-year bond was issued in Mexico since 2001. So this allows us to have a relatively long period to do the analysis and threshold estimation. The main results is that first, the slope of the yield curve seems to anticipate the behavior of economic activity, but only when the term premium is above a threshold. And the estimated value of this threshold depends on the forecast horizon and measure of economic activity. Similarly, we find that the slope of the yield curve has predictive power for probability of a contraction, but only when the term premium is above a threshold. And finally, also we estimate a linear model using rolling regressions, and we find that the predictive power of the yield spread seems to weaken over time. So now in terms of the data, so the idea here is that we are going to regress future output. So that's output between T and T plus K, the difference is the growth rate between these two periods. And this is going to be a function of the yield spread at time T and some control variables. The yield spread is going to be the difference as between the 10-year bond and the 3-month interest rate. That's usually the definition of the yield spread that is used in the literature. And then for control variables, we use 3. One is the real funding rate, which is an indicator of monetary policy. These control variables have been used in this literature very commonly. Second, the slope of the yield curve for the US. There's also a difference between the 10-year rate and the 3-month rate. This is to consider the international financial linkages. And finally, lag output. And the study period goes from 2004 to 2019 using monthly data. So this is the framework, the data that I use. Regarding the data for the term premium, it's a latent variable, so it has to be estimated. And actually, we took the estimates by Aguilar et al., which is another paper that actually was presented in this conference. And the idea here is to, as I mentioned before, the 10-year bond rate can be decomposed into 2 components. One is the term premium, and the other one is the expected 3-month interest rates over the next 10 years in this case. And so the idea here is that to estimate these expectations of short-term interest rates in the future using information from financial markets. So this is what these authors do in the paper is they use the average of three models. There are 2 term structure model, and also there is they use the swaps for the interest rates at different maturities. So the idea is to use the information from financial markets using these factor models and also these swaps to extract what are the expectations of agents over the future for interest rates at different maturities, and taking some assumptions on the non-arbitrage between these interest rates at different maturities. Okay, so to have some idea of the relationship between the yield spread and future output, this graph shows the dynamic correlation between output at between the yield spread at time t and output at time t plus y, where this is y in months. So what we can see is that there is a positive relationship between these 2 variables. And the relationship seems to be the highest between the months 8 to 28 months. So like between 1 year and 2 years. So that's where there seems to be the highest correlation between yield spread today and the output in the future. So this indicates that there is in fact this relationship. And this graph has the similar message. So this is the red one is the yield spread at time t, and the blue one is the yield, the output in the future, 12 months ahead. And what we can see is that in general, there is a positive correlation between these two variables. But this is particularly stronger during after the global crisis in 2008, 2009, and before 2017. And these periods, in fact, are also the ones where this term premium in green is higher compared to the periods before the recession and after 2017, where in general the relationship between the yield spread and future output seems to be lower in these periods. So this has like this gives like some idea that there seems to be a nonlinear relationship between these two variables when we're going to look in the model. So there are going to be three models. The first one is just a linear model. Future output is going to be regressed against spread at time t. And the future output is defined in two different ways, as is commonly used in the literature. So one is the cumulative change of output between the month t and month t plus k. This is just to make it annual. See, this is the first measure. The second measure is the marginal change of output, which is basically the annual growth rate of output. So the difference between output at time t plus k minus 12 and time t plus k. And we have this k is the forecasting horizon. And in this case, we use 6, 12, and 24 months forecasting horizons. And because these regressions have some overlapping because of output because of the way it's defined. So we use the New West standard errors. And the size of the rolling window is 72 months, but we use different alternatives and the results are similar that I'm going just to show now. So these are the results of the rolling windows estimation. So this graph shows the coefficient between term spread today and output k months ahead in the future. So that's 6, 12, and 24 months in these different colors. And also the term premium average rolling window also for six-year average. And what we can see here is that the correlation in this axis is positive in general, which means that if the yield curve flattens today, then output is expected to decrease in the future. But also that what we can see is that the coefficients seem to decrease over time. After 2014, so in the same periods, there seems to be a lower predictive power of the yield curve. And at the same time, the term spread also seems to decrease over time. So this could be related. This could be related to the stronger central bank credibility, which lowers the term premium. And also, what we see then is these are the two main messages. One is that there is a positive relationship, but it's going down over time. This is similar for either we use cumulative or marginal change of output as a definition. Okay, so this was the first model. Now we go to the threshold model to look at the nonlinear relationship. So again, the dependent variable is going to be output between t and t plus k, future output. And in this case, explanatory variable is going to be the yield spread at time t. But here, this is an indicator variable. So here, if the term premium is below the threshold, and this is an indicator variable when the term premium theta 3 is above the threshold to be estimated. So these are parameters to be estimated, these 5. So the coefficient associated to the yield spread is going to be alpha 1 if the term premium is below the threshold, but it's going to be alpha 2 when the term premium is above threshold. So that's how we're gonna get this possible difference between when the term premium is above or below the threshold. And there are going to be 3 control variables that I mentioned before. Just the monetary policy rate, the yield curve for the US, and lag output. And this model is going to be estimated by nonlinear least squares.
Sorry, Raul, if
Yes.
you want to stick to the calendar, you have 5 minutes only.
All right, that's good.
Okay.
Okay, so these are the results. So this alpha 1 is the, as I mentioned before, is the coefficient when the term premium is below the threshold, and alpha 2 when the coefficient is above the threshold. What we can see is that alpha 1 in general is non-significant, but alpha 2 is in general significant for different horizons, forecasting horizons shown here. So what we can see here is that the yield spread is going to have predictive power over output only when the term premium is above the threshold. So in this case, where these coefficients are significant. And the values for the term premium over which there is this positive relationship are when they are above this estimated threshold shows in this column. So the idea of using the marginal change is exactly the same as using the other measures, so results are robust. And this graph is to show you this like in a graphic way. So we have the figure that I showed you before, but now I add this estimated threshold for the term premium for 12 months horizon. So this the gray areas are the ones where the term premium is below the threshold, and this seems to be the areas where the relationship between this term spread in red and the future output in blue are the lowest, compared to these white areas where the relationship seems to be high. Finally, this is the Probit model. So the difference here is that we have as a dependent variable the probability of a contraction, and this again depends on the term spread in Mexico and the term spread in the US. And then the model with threshold. So we're going to estimate 2 models. One is the model without threshold, and then the model with threshold, as using the similar ideas that I just explained before. So in this case, gamma 1 is going to be the parameter associated to the spread when the term premium is below the estimated threshold, and gamma 2 is going to be the parameter when term premium is above the estimated threshold 5. Okay, so these are the main results are shown in this part with the model with threshold. So it's gamma 1 is in general non-significant, as I before, and gamma 2 is in general significant. So again, the yield curve seems to have predictive power over the probability of a contraction in the future, but only when the term premium is above the estimated threshold, which is shown here. So these are the estimated probabilities of facing a contraction in gray. These are the contractions defined as 2 consecutive quarters of declining GDP, as usually defined in the literature. And this has what this model shows is that, let's say the model estimates a higher probability of a contraction in this period where actually we had a contraction, and the fit of the model with threshold seems to be in general better than the model without threshold. So the estimated probabilities are higher here in the periods where we actually had a contraction. So just for final remarks, we have that this. So we have this. We are finding that the yield curve seems to anticipate the predictive power of economic activity, but only when the 10 premium is above a threshold. So the idea is that if the 10 premium is relatively low, then the yield curve can be inverted with a small decrease in the expected short-term interest rate. So we believe that this component is the one that drives expectations of output in the future. So this will have less predictive power, or the adjustment in the expected short-term interest rate will be lower. Therefore, we will expect lower probability of a contraction or a lower expected decrease in economic activity in the future. So there are some important implications of this analysis. From the policy perspective. Our findings suggest that the decisions by policymakers and forecasts should be adapted to consider this non-linearity, and also that this should probably be considered in models that link the yield curve with future output. And finally, future research could look at alternative non-linearities using different threshold variables, for example, and also considering possible endogeneity between future output and the yield curve. Okay, so this is, I don't know if you have like any question or any comment, or we'll do the questions for the end of the presentation. I don't know what do you think?
Yes, Raul, I think that according to the program, the questions are at the end. So
Perfect.
If you are done, if you don't mind, so we step to the following presentation. Thank you very much.
Thank you.
And then according to the program, we have 15 minutes left for questions. Okay, so, okay, let me share the screen. Okay. Can you see my presentation?
Yes.
Okay, thanks. Okay, so thanks for attending this session, and thanks for accepting our paper in this year's LACEAS conference. It's a pleasure to be here. I hope next year we're gonna have a LACEA conference being on site. But okay, let me start. So the title of our work is Latin American Falls, Rebounds and Tail Risks. This is a joint paper done by Luciano Campos, which is me. I'm from the Universidad de Alcalá in Spain, and my co-authors Danilo Leiva León from the Banco de España and Steven Zapata from the Banco de la República. The usual disclaimers apply. Okay, so sorry, I cannot see my own presentation. Okay. Sorry. Okay, so and the motivation for this work is that when we observe Latin American countries, we see that the business cycles within each country are very heterogeneous, in the sense that the peaks and the troughs that we observe are of different magnitudes. You have magnitudes of different peaks, magnitudes of different troughs within each country. So suppose we want to track down turning points in real time. We want to do nowcast, for example. We need to consider this unstable environment, okay? Because having an accurate economic outlook is relevant for several institutions. For the central banks, it's important to know the timing and the magnitude of the crisis for policy stimulus, or booms for policy tightening. Okay, you can also think from the perspective of a multilateral institution. It's important because they monitor real activity in real time, and also from the point of view of hedge funds, and thinking about an investment decision that where you want to diversify portfolio. You want to know what is the outlook of a specific region or country on real time. Okay? So this heterogeneity that we observe in peaks and troughs between countries in Latin America as elsewhere has become very evident during the COVID crisis. So let me show you the evolution of GDP of Brazil, Mexico, and Peru, just to put 3 examples, but similar pictures arise when we plot different countries in Latin America and elsewhere. This is what we have in the upper plot before the COVID. Okay? So we have some ups, we have some downs, quite heterogeneous. For example, the global financial crisis was a much stronger crisis than other milder crises that we observe in the region. But when we take into account the COVID, this picture is completely distorted. This is what we do in the second plot. So we can see here that the fall that Latin American countries experienced during the COVID and the posterior rebound observed when the lockdown measures were eased have completely outweighed the previous crisis in magnitude. Okay, so this is kind of supporting the view that we need a model which is flexible enough in order to assess real-time activity in real time. Okay. So what models do we have out there if we want to do a real-time assessment of business cycles in Latin America? So we have the seminal work of Hamilton, 89, where he uses a univariate model and he uses constant mean. So these are all Markov switching models, and then where there are 2 states, expansions and recessions. And in the seminal work of Hamilton, the means of recessions and the means of expansions are constant. So this is not flexible enough in order to capture the heterogeneity that I was talking about. Okay. Then we have the work of Chauvet in 98, where she includes multivariate into the analysis, which it's good in terms that it gives you more flexibility, probably increasing the forecast frequency, because you can include monthly variables, not only GDP in quarterly frequency, but still she uses constant means which is non-convenient for a heterogeneous framework, for a heterogeneous environment, sorry. Then we have the work of Io and Kim in 2016, which is time varying, which is very convenient, but because now you can adapt for different means of expansions and means of recessions, but still univariate, which is quite restrictive. So there is a new model by one of the co-authors of this work, Leiva Leon and others, in 2021, which is multivariate. It's allowed mixed frequency of variables, but it's time varying. And this is going to be a model which is going to be flexible, more flexible than the previous ones, and especially relevant for the present conditions of the COVID. Okay, so what we do in this work is we estimate that model, the new model of Leiva Leon and others, and we feed it to the biggest Latin American economies. What we're going to do is we're going to inference aggregate activity, the turning points of aggregate activity, and we're going to measure the size of expansions and recessions. And with this, we're going to provide several indexes of Latin America, and which we believe are going to be important for assessing the economic outlook of the region. We're going to evaluate recession risk in real time, and at the end, we're going to look at the impact of the US conditions on Latin American activity. Okay, so let me show you very quick the model we use. So this is a dynamic factor model where we have YT, which is a real activity vector of which has a lot of variables, such as the GDP and other monthly activity indicators for each country. Okay, so these real activity indicators are going to be decomposed into a common factor, we're going to call it F, and an idiosyncratic component U. Okay, so the common factor at the same time is going to have different states. We're going to have a state of expansion, where this latent variable S is going to be equal to 0, and latent and a state of recession for ST equal to 1. This ST is going to be estimated by us. Okay, so we're going to have these means of expansions mu1 and recessions mu0, which conveniently are going to be time variable. So when we estimate this model, we're going to have these factors, which are going to be for us what we call the monthly activity indicators, because they comprehend a lot of activity indicators for that country. And when we estimate this latent variable ST, this is going to be our monthly recession probability for each country. Okay. So the data that we use we include the biggest Latin American economies: Argentina, Brazil, Chile, Colombia, Ecuador, Mexico, and Peru. We were planning to extend this to more countries as we get more data of these countries, but these are the biggest Latin American countries. So we can have a quite a realistic picture once we include these countries of Latin America. And we include not only quarterly GDP, but also some monthly activity indicators on hard and also soft activity indicators when we have them. For example, in the case of Ecuador, the Global Confidence Index. Okay, so this is what we get. I'm going to show you the example for only one country, just for the sake of time. And we have for example, let's look at Brazil. We have in the top panel the evolution of real GDP growth, and we have in the middle panel our estimation of the monthly activity indicator, this factor that we estimate, which is tracking down pretty well the real GDP. We have monthly recession probabilities, which is going to be between 1 and 0. 1 for a high recession probability, 0 for a low recession probability or high boom probability. And the flexibility of our model is allowing us to capture all crises. So if we want to estimate this model in real time, for example, you want to capture big crises, but also you want to capture probably not so big crises, milder crises. You know? So this model is flexible enough to capture a big crisis like the global financial crisis or the COVID crisis, but also crises were not as big. For example, the social unrest we observed in Brazil in 2016, which produced a decrease in activity, is captured by our model. This wouldn't be captured by a model which is not flexible to account for different magnitudes of crisis. Okay, so this is what we get. We're going to get this based on these estimations for each country. We're going to build Latin American indexes, and these Latin American indexes are, we think, we would like them to be used probably by anyone who's interested about the region to know about the evolution of activity and the state of the activity in the region. Okay, so we have the Latin American, what we call the Latin American Weakness Index, which is a weighted average of the probabilities of recessions. So this weighted average is this omega here, and the probabilities of recessions is this S. So the weighted average is related to the size of the economy. Okay. So we can see here that the model can detect the increase in probability of recession during the global crisis, also some previous crises, you know, like the crisis in '99 in Brazil, when the real devalued, and the milder crisis with the social unrest in 2016, and the COVID crisis. Okay, and here we can do also a variance decomposition, which can be interesting to see which country contributed to the weakness of the region in a specific moment in time. So this is what the bottom panel shows. So we can see that, for example, Brazil and Mexico are the who contribute the most to this Latin American weakness. But still, we have times where some other countries contribute as well. For example, Argentina in 2001, during its own idiosyncratic crisis, and Mexico and Chile also in sometimes, for example, during the COVID, we have Mexico and Chile contributing a lot. Especially Mexico and Colombia in light blue and Chile and Colombia. Chile in light blue and Colombia in green, contributing during the COVID. If you note here, there is a contribution of Colombia in lately, probably because of the social unrest in Colombia that Colombia has experienced in the last months. Then we can provide another index, which we're going to call the Latin American Activity Index, which is a weighted average, of the weighted sum of the factor. Okay, this factor is going to be the activity index for each country. If we do a weighted sum of that factor for the whole region, we can see the monthly aggregate activity in each region. Okay, so again, we can see the sizable impact of the COVID and the posterior rebound, which is kind of losing momentum in the last months. Okay. Okay. Then we can also build another index that we propose that is not only not doing the weighted sum of the factors, but of the means of the recessions and expansions. So by doing this, we can get a glimpse into the intensity of the phase that we are experiencing, the boom or the contraction. And this is what we call the Latin American Intensity Index. So this is good for comparing different crises that the region experienced in the past, and this is estimated on real time. Okay, so with data until that precise moment of time, and again we can see the strong impact of the COVID, even stronger than the global financial crisis in 2008, and we can see the strong recovery after that is unparalleled with the previous recoveries in our sample, and which is again losing momentum in the last months. Okay. Then we can, with this Latin American Intensity Index, we can do several things. So we propose many things that we can do in order that can be useful for assessing the risk, for example, of expansions or recessions. More risk of expansion between quotations. Okay, so here in the top panel we show what was the distribution, okay, of the Latin American Intensity Index at the beginning of the COVID crisis. Okay, February 2020 in green, there was a probability already of recession, so we can see that Latin America was already not doing so well even before the COVID started. Then, of course, as we move into the COVID, then we had in March in blue line, we have March 2020. The probability of recession increases, and if we move a little bit onwards on April 2020, we are even more into a probability of recession. Okay, and this is in the bottom panel we observe the estimations, these distributions, but in 2021 when the countries were recovering, okay, already in the rebound after the lockdown was eased. So we observed in green March 2021 where the probability of expansion is quite strong, but as we move on, April in blue and May in red, we see that this expansion again is losing momentum, and we are getting closer to a new probability of recession. Okay. Then we propose also to use higher moments of the distribution of Latin American intensity indexes in order to assess real-time risk of in Latin America. So to do this, we were going to use the skewness of the estimate of the distribution of Latin American intensity index. We're considering that this skewness is counter-cyclical. Okay, so in the sense that when we have for example, here in 2010, when the countries were experiencing the commodity boom, these were good years for the region. We were having higher risk of recession, let's say. Okay, and this is nothing when we compare it to the risk of recession that we are facing in the last months in the region, as the countries started to ease the lockdowns applied of the COVID, and the economy went back on track. The countries experienced this rebound observed, but the rebound is having a high risk of recession, very high risk of recession, as we observed in the last months. Okay. We can also use kurtosis, which is going to give us a sense of how outlier prone is our distribution. So typically we consider that the kurtosis higher than 3 indicates that the distribution is more outlier prone. So again, this also is good to compare different magnitudes of risks. Okay, so again, there was risk of the recession before during the 2010, 2016, but the ones we are experiencing now, even with the recovery after the COVID, are high. Okay. And lastly, what we do is we analyze. We think of let's try to think of an exogenous variable that could affect this Latin American intensity index, and a natural variable that we can think of is the U.S. financial conditions. So we take the U.S. financial condition index, which is an index built by the Chicago Fed, which comprehends a lot of variables, not only interest rates, different horizons, but also another different financial variables like values of stocks and others. So with that, they build this U.S. financial condition that when it's high, it means that the financial conditions are becoming tighter. Okay. So then we plot this U.S. financial condition in red against the Latin American intensity index in blue. So we can see that, for example, here in the global financial crisis, we observe that these are negatively related. So there's tend to be a negative contemporaneous relation between the U.S. financial condition, Latin American intensity index in certain times, and this is very intuitive. You know, in certain times, in these times when U.S. financial condition becomes tighter, like in the global financial crisis, then Latin America suffers, and there is a downturn in economic activity in the region. Okay. So what we would like to know if this relationship between the U.S. financial conditions and the Latin American activity is changing. No, is it the same before? Was it the same in the global financial crisis than it is now? And to do that, we use local projections, and we estimate the Latin American intensity. We estimate the effect of the financial conditions of U.S. against the Latin American intensity index in a time varying fashion. So we want to know how this effect of the U.S. financial condition changed, if they did, affecting Latin America. And to do that, we control for what happened during the COVID. Okay, we use a control to the number of an index of mobility that we want to get rid of the COVID effect, let's say. And this is what we get. Okay, we get that it's not the same. I mean, this would be the impulse response function, which is time varying. You know, so we have a different impulse response function for every moment of time. And we would like to know if this response of U.S. financial conditions tightening, so this the effect of a tightening U.S. financial conditions, we want to know if this has changed and how the responses have changed in Latin America. So we observe that the particular thing we want to know here is, for example, comparing with the global financial crisis, did the response of Latin America, is it different or not from before? Even controlling for the COVID, you know. So we observed that the contraction, I mean, the contraction was higher during the COVID, but if we look at the confidence bands, it was more persistent before. So we have a more persistent effect before than now. And there.
Sorry, Luciano. You have just 1 minute left. If you want to wrap it up, we are just.
Yeah, I'm just one slide from
Good.
So that's it. Thanks. Okay, so as I was saying, how can we interpret this change in persistent, before more persistent than now, the effect of U.S. financial conditions on Latin America? Probably is because in general Latin American countries are more from a macroeconomic perspective, they are better managed. Okay, so we have lower inflation, we have more counter-cyclical measures adopted in countries in the region, like let's think about Mexico, Colombia, Chile, and this probably is causing this reduced persistence of the effects of U.S. financial conditions on the region. Okay, so to conclude, we use the novel approach of Leiva, Leon, and others to assess the Latin American economic outlook. This framework provides high-frequency real-time updates as new information of Latin American economies is released. So it's very convenient to know in real time the state of the economies in the region. We built several indices which we hope are useful for policy decisions and also for investors probably as well. And we analyze how the effect of U.S. financial conditions over Latin has changed over time. We also verified that during the COVID, there was a strong fall and a posterior rebound, which is kind of losing momentum in the last months in the region. Thank you very much. Okay, so we are on time, no? So now we have Juan Carlos Muñoz Mora.
I'm finally here, Lucian. Thank you so much.
Okay, thanks. So we are on time, so we should be finishing at, you should be finishing at, okay, we have 25 minutes, okay? Or 23 minutes, let's say, to be on time. Then we have 15 minutes for questions.
Okay. Thank you very much, Luciano and Raul, and I'm really sorry for this technical problem that I had at the beginning of this meeting. And this is my third computer. I'm finally working. I'm finally here. Okay, so today I want to share with you a project that we have been working now a couple of years. Now is that this is a part of a larger project in which we are trying to build new proxies to measure inequality from different perspectives. This is a joint work with Professor Marta Reynal and José Montalva from the Pompeu Fabra University. Okay, the main motivation of this paper is just thinking about the fact that the increase of inequality around the world in the last couple of years. I guess this is something that all of us agree that this is a critical problem, not only for us, but also this is like one of the biggest questions that we have from the growth, but also from the economic structure in the different countries, in the US, in Europe. Let's say this is a huge topic, and one of the best, and let's say one of the main target as an economist is trying to understand this inequality, how this inequality look like, and how it's going to be the best way to measure this inequality. And there are many proxies to do it. So, but in order, from the empirical point of view, when we want to choose one of these elements or these indexes or these approaches to inequality, we usually face some constraints. I mean, the first big question when we want to study inequality is trying to choose which indicator do you want to use, right? So, because there are many indicators, if you have the Gini indicator, or if you want, or if you get I mean, other type of indicators, and then once you choose the indicator or the index, the following question will be the source of that information. So from what information I can estimate this inequality. And there are like three main sources of information: the income, taxes, consumption. Let's say these are the traditional problem. But even though even these sources has, let's say, some well-known problems related with the measurement errors. I mean, the problem with the top coding and the distribution bias that we have in some of these in this element. So somehow we have some indexes and we have already some sources for that, but thanks to these these difficulties that they are building this index, we don't have like a unified way to measure inequality all around the world. So we have, if we take the same country with different sources of inequality, you can find some big difference. Just in Spain, if you take the index for from the World Bank, and you take from the least data set, the Gini index in inequality, and you take the national accounts, the index that is estimated by the Spanish government, then you find that there are almost until 0.3 difference in these indexes. So the traditional indexes in general are they present having, they show that have some limitation in order to actually approach the real state of inequality. And based on this context, there are new ways to measure these elements. And I guess the most promising part is the use of satellite imagery or satellite information to estimate in the economic inequality. We know, let's say now is already sort of an agreement for us as an economist that using luminosity as a proxy of economic activity is a good proxy for estimating the activity. I mean, the size and the evolution of the economic activity in different countries. So in this paper, we want to estimate how we can exploit this new information, this new data from luminosity at night, and using other information from the satellite to build some measure of inequality in order to try to understand that, to give some of a robustness check of the existing indexes, but also to provide information in these places where the data is not good enough, right? So what we want to do, basically, we want to build on two main areas of research. I guess there are a couple of papers that has already worked on this link between using luminosity and inequality. They basically use just the intensity of night light and the information that is built on that from that information, and based on that, they build something that we call the unconditional inequality, because they don't control for any other. They don't take into account population. They basically take the intensity using the disaggregation based in the pixel level in inequality, and they just build the inequality index. And there are another way to use this kind of data sets for estimating inequality that was basically started by Alesina 2016, in which they start combining luminosity data sets with population data sets. And they wanted to, and somehow, I mean, they were one of the first who suggest that luminosity per se, I mean, if luminosity per se is a good proxy of the economic activity, then the luminosity per capita will be another way to proxy the somehow the welfare at the individual level. So we want to build from that part, and basically our approach is just we want to take all the satellite information that is available at the using luminosity data set. And basically, as you know, I don't know if you are familiar with this kind of data set. This data set is built, and there are like big pictures that is basically composed by a small pixel, and every pixel in this information, for instance, in this example, we have a pixel that is around 700 meters per 700 meters for the entire world. So that's basically taking all the world and splitting in these small boxes. And based on these small boxes, we are going to have the information from the luminosity and also the population. So basically, our approach is just let's take the layer of luminosity and then take the layer of population. And then you have some income welfare and proxy for each individual at the pixel level. So then we're gonna have some measure of the individual proxy and the wealth, and then just take on this small measure, we are able to estimate not only the Gini index but also any index about the distribution, because now we are able to decompose or any geographical area in the world in a small pieces in which we are able to observe the welfare per capita. In ideal, our expectation basically is just having one layer, one satellite picture that is completely aligned. Both, I mean, the luminosity is gonna have the same location. I mean, this is more or less the example that I'm giving you here. So our expectation is just imagine that you have a population raster data and the luminosity raster data, and somehow what you would like to find as a researcher is that they are completely aligned and you have the information exactly for the same geographical area, but this is not what is the reality. In reality, what you have is that you have these information are not aligned. So basically what you're gonna have is that the location of the pixel population is gonna be different from the location of the pixel of luminosity, and something that we have to solve, and something that we wanna that is gonna be part of our methodological contribution is starting to solve this problem, just combining these two data sets. Okay, so let me show you, and in general, what is the data that we are gonna use. There are many data sets, basically two main data sources that we are gonna use. We are gonna use, this is at the beginning I told you this is a part of a large project, that this paper is just the first part of the project, but because we are taking all this information that is available from the luminosity from NASA, that is available from 1992 till 2014. This is the initial project. Now that migrated to a project called BIRS, in which they improve the length, they improve the satellite, and now the information is much better. But in this initial project, we want to build these indexes using this information that is gonna help us to build like a long-run trend in terms of inequality for this. So we are gonna use all the information coming from 2000 and 2014, and the different colors are different satellites that are available for this. In every year, you can have two satellites that are taking pictures of the luminosity in the air. So something that we want to use all this information in order to choose what is going to be the best proxy and the best source of information in the luminosity point of view. And if you are familiar with the luminosity data set, you know there are some potential source of measurement errors that are just well documented. First, that this information is truncated. There are just because the technology that was the satellite has in the lens, they have some they were unable to distinguish between the Manhattan and New Jersey, for instance, because they have some limit. They have some limit in order to the sensitivity of this lens in this kind of satellites were not enough to capture high intensity light. So one of the problems of this data set is that it's stop-coded or it's truncated. We are going to offer a solution for this. And another problem is going to be the over that thanks for, because it's light, you can also over magnify city size just because the projection of light when the lens is taken from outside. There are other technical problems for this, like fires and other. That is, let's say, a traditional, let's say, standard procedure to clean the data set. So, and for population, we are going to use a data set that is the Landscan population global model. This is what is called the population during day, because there are one population, other information, raster data that is also available at the geographical level, but it's based on luminosity. So we want to get some population data that is built again at the small geographical level, and but during day. I mean, because we don't want to have some correlation between the nightlight and the population. So just to have a general sense about how this population data is built, what they basically did is, I mean, what they basically do is that they get the smallest sensor unit that is available country by country, and then using information about roads and other infrastructure information, what they did is they automatically locate population. I mean, if imagine if you have the smallest census data is a village level, and then using satellite information about where the population is and where the town is, then the landscape global model, what it's gonna do is that it's gonna allocate most population in the places where there is evidence for, I mean, as I told you, for instance, where more urbanization is, or when the settlement is located. And okay, so what is gonna be our main contribution, right? So as I told you, what we want to do is just not just basically doing the index, but also to offering solution for the traditional problem of using these data sets. So the first problem that we are gonna do is that we have some problems related with the, as I told you, these pixels that are not completely aligned. So we need to guarantee that these are going to be aligned, and therefore we are going to be able to find our index of inequality per capita in each pixel. So we offer these things, and also we have to deal with the problem with the top coding. For this, we are going to use we part from the traditional top coding technique, but it's based in the local Pareto, in the Pareto law. But now we built an adaptation for the local Pareto, because what we want to do is just basically give the sense of this. Let me give you a couple of examples of what we are talking about. If you take, for instance, one place at Barcelona, imagine this is in this right hand side. This is the picture, the nightlight of Barcelona during nights. And if I just take all the pixels that are located in this latitude, so what you have here, this is in the app, in this graph we have the luminosity. So if you see that where you are close going to the center, the information is saturated. You see that in the center, the maximum value that we are going to have luminosity is 63, right? And then the next, the second panel will be the population that is also coming from the land scan. And you see that most of the population are here. Once we use our correction, so this is, we do the correction for different alphas. So for instance, when this is with no correction, but now when we have some correction, for instance, with alpha 2.5, look how we are able to solve the truncation problems. Now the limitation is not 64, but now 60 is 100. So it's not let's say, it's still imperfect, of course, because this is more or less the main restriction when we have these kind of problems, but still we are able to at least to solve a bit more the problem of truncation. And this is going to be exactly the same with this is the small dashboard where we can have some country. Let's use Medellin, where I'm located. Look the problem of truncation in Medellin. This is Medellin. This is the nightlight in Medellin. Again, this is the information. Look the information without any correction. Basically, it's going to be a complete line here. But once we use our adaptation of the Pareto local collection with different alphas, look how we are able to solve the problem with this. So this initial contribution of solving the Pareto, let's say the Pareto problem, the top coded problem, the truncated problem of this information. Now we are able to find to get the distribution and look how our welfare, that will be our final, our main unit of analysis, our welfare per capita per pixel is look like in the case of Medellin. And that is going to be available again for every year from 2000 to 2014. So, well, as I told you, yeah. Go ahead.
You have 5 minutes left.
Yeah, okay, no, I'm fine. Yeah, based on this, now we are able to find some, let's say, results. I don't want to get like more into detail, but this is more or less our results from the genes. And you see that are quite stable in the different years. So we are able to find, again, this is the results for only for at the country level, but we also have the information, for instance, at the subnational level, right? So look, and one of the good things about having this information is that since we are able to get the information at the since we have the individual information, look, we are able to build, for instance, some intermediate steps from the Lorentz curve, like the Lorentz curve, for instance. Look, for instance, any country. Look, for instance, Spain. If I take Spain in 2014, we are comparing the Lorentz curve built with the this is the world inequality data set where they build the Lorentz curve. The blue one is the World Bank, and the orange one is ours. So you see that there are a strong correlation between what we are, what the traditional measure they have and what we are estimating in this information. And this is quite stable in at the national level and in those places where we have some information also from the regional. So the following up question is, but okay, how good are our estimates? I just showed you that our estimates are quite stable and quite similar to this. So for doing this, what we are gonna do is we are gonna take the tradition. Look really ugly, but we are gonna use the traditional data sets from Gini and from the World Bank. This is the traditional Gini, and this is the means from the 1, 2, 3, 4 different sources. This is the most traditional Gini sources. And look how look like our, for instance, our MIFA. This is our Gini with other. Look how it's gonna look like, for instance, United States with Spain, with Colombia, with Brazil, with the Dominican Republic. So you see that we are able to see that. But let's imagine more or less the idea that we don't have. So let's imagine that we don't believe that perhaps we have different sources. So let's imagine that instead of substitute, what we are measuring is like, as I told you that we have different, the different Gini has different measures. So if we assume that every Gini has to play part, is telling part of the story, so we can put them together and using a structural analysis. Basically, we are going to use exploratory factor analysis, and we're gonna put together, and we are gonna try to get the common factor that is based among all the Ginis together. The 3 Ginis that are coming outside the traditional Ginis and our Ginis. And what we found is that our Gini is highly correlated with the common factor in from base for days. And basically, this is the determinants of the difference between the predicted Gini values come from our structural model and the Gini. I just want to show you a couple of things, Luciano. I guess I have still a couple of time for this. But basically, what we have here is the possibility to do this comparison between all the different things. For instance, this is the case of Ginis at the subcountry level. This is the case of Colombia, and again, the information is going to allow us to have information. For instance, at the Lorentz curve, for instance, look again. Let me take Colombia. This is the region of Colombia. Now, for every region, I'm going to be able to get the Lorentz curve, but also the Gini. But if I take other countries like Spain, let's take Peru, for instance, we have again other countries, and then we have the information. I guess so. In general, we find that our method could be used as an alternative measurement of Gini indexes. We know that this information, as our result shows, are quite consistent with the traditional measures of index, and what we are doing is offering, and that basically opened the door to estimate our Gini in places where the information is not available, like countries or even a sub-regional level. We have some limitation based on the resolution of the data sets, but with this analysis and this methodological contribution, we are able to put these things. And now the new project, as I told you, is we are now building this adapting this strategy to the new data set, which is the BEARS. This BEARS has an important characteristic that is completely different to the information that we did this paper, just because the BEARS is not truncated. So we have, with this information, you don't need to correct for the top coded because it's already, the lens now is able to capture that information. Luciano, I guess thank you so much. I'm really looking forward for your question. I know.
Okay, thanks, Juan Carlos. So yes, we are on time. So we can have some questions. I don't know if there are any of the attenders that would like to pose a question to any of us. Okay, maybe to break the ice, I can start myself. I have a couple of questions for both of you, Raul and Juan Carlos. So very interesting, both of your work. So I would like, maybe I have a question for Raul and a question for Juan Carlos. So maybe I will do both, and then. So Raul, if I what I understand from your work is that there is a threshold from that you have estimated in where the yield curve, I mean the forecasting power of the yield curve it's not strong enough. It's not strong. I mean, and you have given us that threshold, but I didn't understand basically what is the interpretation of the threshold. So if you could translate it to words, what would you say? So in times where the difference between the 10-year bond and the short-term bond 3 months is below or above that threshold, then there is no forecasting power of that variable on activity. That would be the interpretation.
Okay. So the threshold here is for the term premium. The threshold variable is the term premium. So we are looking at as you said correctly, the predictive power of the yield curve to anticipate future economic activity. And this is going to depend on the threshold for the term premium. The term premium is the compensation that investors demand for holding a long-term bond instead of a short-term bond. So there is going to be and this is one component of the long-term bond. The other component is the expected short-term interest rates in the future, according to the expectation hypothesis of interest rates. So what's going on here is that, as you said, like below some threshold for the term premium, the yield curve is not going to have predictive power for GDP. And the thing here is that if the term premium is low, then the yield curve can be inverted with a small decrease in the expected future interest rates. So we believe that this information on the short-term interest rate is the one that has the expectations about future activity, because activity depends in big part from interest rates. Then the yield curve can be inverted with a small decrease, and we will expect a lower probability of a lower decrease or lower increase in the probability of contraction in the future, or a lower. We will not have the yield curve will not have a very strong predictive power for GDP in this case. So did I answer the question?
Yeah.
A little bit more clear.
Thanks.
Welcome.
Okay, so maybe I can ask something to Juan Carlos. So so very interesting your work. So you said that that there are the Gini coefficient is the data for the Gini coefficient is probably not so good in some areas, some countries. So with your new satellite information that you provide, that you collect, let's say, you can provide an index which is you're able to replicate the Gini coefficient in some places where you do have that information, but in other places, I mean, you guess that information could be a supplement because you don't have the Gini coefficient. No, that's what you do, if I understood correctly. So my question, I guess, it's you're based. I mean, your information. I mean, your assessment of inequality is following this luminosity that you explained at the beginning of the presentation. So couldn't it be, for example, if we think of Colombia, if we think of a country like Colombia, couldn't it be that there is an area where there is less luminosity, but that doesn't necessarily mean that there is more inequality? Because I could think of a rural area that probably people live. I mean, that there is not a big deal with inequality, but the luminosity is not as strong in another area of Colombia where probably there is more inequality. So
it's true, Luciano. I guess one of the main constraint of this data set is that somehow we are pushing the idea that luminosity per se is a well proxy of income or even welfare, and they have some caveats, of course. As you said, there luminosity per se is not sometimes is not really related with income. That's the case of Norway with the saving program that they have. So we have some areas in Norway that they have low emission during night, but not because they are less developed, but just because they have this saving program, right? So these kind of constraints of using this data set are present, and unfortunately, there is no way to technically solve that problem. And as I told you, but basically what we have right now is that this general agreement that the data is not perfect, but it still give us this sort of information. But despite of this weakness of these caveats of using this data set, I guess something that is really important and perhaps that we can capture with this data set is this possibility to do this zooming in some areas and trying to disentangle this kind of difference at the territorial levels to see, for instance, not only the Gini at the national level, but also the subnational level, and even at the village level, and basically trying to understand this different and this heterogeneity of inequality in the different territories. So I guess this is one of the things. I know that not solve your main concern about this data set, but it still give us this opportunity to understand this different inequality at the territorial level.
okay, thanks. So I don't know if there are any more questions. Okay, so we are done. Thanks very much, Juan Carlos and Raul, and those who attend these presentations. And thank you for the organizers. And let's hope we can meet someday personally.
Yeah, thank you, Luciano.